Hi, we're very proud to introduce colored wiring diagrams for several new BRP products. Starting with model year 17, you can expect to find colored wiring diagrams for select products on the Knowledge Center. Color wiring diagrams will help identify and understand circuits, follow power, grounds, and signals easily, know what type of circuit you're testing, anticipate the results of a good test, and easily trace back the cause of a bad test. You may be asking yourself, how do I know if a black and white diagram is available in color? If the printed diagram has a line color legend, a color version of the diagram is available on the Knowledge Center. You can download it from the shop manual directory. First off, let's clear up what the line colors aren't. The color of the line on the diagram does not represent the color of the wire on the vehicle, although sometimes it can happen by coincidence. If you're looking for this wire on the vehicle, you have to look for a yellow-green wire, not pink. Now that we know what the line colors aren't, let's have a look at what they are. We now use color to illustrate unswitched 12 volts, switched 12 volts, reference voltage, analog signals, module grounds, digital signals, power control, AC voltage, communication, high voltage. Let's see what it looks like. Unswitched power is represented by a thick red line. Unswitched means that you should always be able to measure battery voltage on the circuit, also known as hot at all times. Switched power is represented by a thick pink line. Switched power means that the circuit is switched on at some point to measure battery voltage on the circuit. Sensor reference voltage is represented by a thin red line. Analog signals are represented by a thin blue line. The voltage in an analog signal circuit can vary between a minimum and a maximum. The illustrated TPS sensor produces an analog signal because the signal voltage varies depending on throttle angle. Module grounds are represented by a thin black line. Module grounds are provided by a module, often to a sensor. Knowing the signal wire will speed up the diagnostic process. Here we can see the voltage graph of an analog signal. This is a graph of a potentiometer TPS signal. The scale on the left shows that voltage varies as the throttle angle changes. Digital signals are represented by a cyan line. The voltage of a digital signal does not vary. It is either on or off. However, the frequency of on-off cycles can vary. An oil pressure switch provides a digital signal since it can either be open or closed. A Hall effect sensor produces a digital signal with a frequency that varies according to trigger wheel speed. Here we can see the voltage graph of a digital signal. This is a graph of a Hall effect camshaft position sensor. The scale on the left shows that voltage jumps from 0 to 13 volts as the trigger wheel passes in front of the Hall effect sensor. The voltage does not vary between 0 and 13 volts. It is simply on or off. Power control is represented by a brown line. Power control is similar to a digital signal in that it can only be on or off. A power control circuit is used by a module or a switch to activate a component. A reversible motor can have two power control circuits. In this illustration, the ECM uses a power control circuit to ground the ignition coil, which will ultimately produce a spark. The power control circuit can either function by providing a power or a ground to activate the circuit. Do not confuse with digital signals, module grounds, or other circuits. AC voltage exiting the generator is represented by a yellow line, one of the cases where the line color on the diagram matches the wire color on the vehicle. Communication circuits are represented by a green dotted line. These circuits represent data communication between modules using a protocol, be it CAN, LIN, or any other protocol. High voltage is represented by an orange line. high voltage circuits are not applicable to all wiring diagrams. And now for a quick example illustrating how the colors might help troubleshoot a fuel pump. Let's look at a traditional black and white diagram. It's kind of hard to tell at first what terminal should have power when the unit is running. With colors, we can easily deduct that the fuel pump should receive a switched 12 volts at terminal B. We can also see that there is a power control to terminal A, meaning that something has to activate the fuel pump. If the circuit is functioning properly, battery voltage is available at terminal B and the module controls the ground at terminal A in order to activate the fuel pump. If you have any questions or comments regarding these new wiring diagrams, please post them to the community and we'll do our best to answer your questions.